Hey, sixth graders, welcome to step 6, where you're going to be learning more about climate. Before you start working through this step, I'm going to take about 10 minutes of your time to go over some information that you need that will help you understand what's going on in this step and how it relates to climate change. And the stuff we're going to talk about has to do with Earth's energy flow, what gives the Earth energy and what keeps it warm. Our big goals are to understand where the energy in the Earth's atmosphere comes from. Remember, atmosphere is the layer of gases around the Earth. You're also going to understand the different things that happen to that energy when it gets to the Earth. So let's get started. First off, you should know that on Earth, it's actually pretty warm compared to the rest of the universe. The average temperature in outer space is negative 454 degrees. That is incredibly cold. But the average temperature on Earth here is positive 61 degrees. So compared to outer space, we are a lot warmer. So how do we get warm? Well, to make something warm, like we learned in the first science project we did, you have to give something energy. So the question then is, where does that energy come from to warm up the Earth? And the answer is the sun. The sun is a star. It gives off a lot of energy, and that energy is what warms us up. The energy from the sun gets to us in the form of radiation. And radiation it's in one of your playlists. It's from the Conservation of Energy playlist. You hopefully already know that radiation is energy that travels in the form of waves. So more specifically, the light from the sun, when it hits the Earth, warms up the Earth. And when that light hits the Earth, there's basically two things that can happen. The light can either be reflected or it can be absorbed. So let's talk about what those two things mean. Reflection is when energy bounces off a material or an object. So think about light bouncing off of a mirror. That's reflection. And just like light can bounce off of a mirror, light can also bounce off of things on the Earth's surface and bounce back into outer space. And that's what happens. Some of the light comes and hits the Earth and it bounces off things like the clouds, the ground, even the atmosphere itself. And that light bounces straight back up into space and is gone. So that reflected light does not warm up the Earth. And about 30% of the light from the sun reflects off the Earth and does not warm us up. So what happens to the other 70% of the light that hits the Earth? Well, that light gets absorbed. Let's talk about what that means. When something gets absorbed, it's taken in. So think about a sponge soaking up water. That's what the Earth does to most of the light from the sun. It soaks up that light. That happens mostly in the land and sea. So a lot of the light, when it hits the ground or when it hits the oceans, gets soaked up. It also gets absorbed a little bit in the atmosphere as well. And when that happens, there's a process that happens and it turns the light energy into what we call infrared radiation. Infrared radiation, all you need to know is that it's a type of energy that makes things feel warm. So think about if you've got something that's been sitting out in the sun for a long time. Let's say you have a piece of clothing, like a black sweatshirt. It's been sitting out in the sun for a long time. That black sweatshirt is absorbing the light from the sun and turning that into infrared radiation, and that's why it feels so warm. That's exactly what happens on the Earth to a lot of the light from the sun. So this little picture here kind of shows you the steps. So light gets given off by the sun. That light gets absorbed on the Earth by things like the atmosphere, the land, the oceans, the sea. And those places change that light energy into infrared radiation. And that's ultimately what actually warms up the Earth, is that infrared radiation. But why do we stay warm? Because let's think about it. The moon gets energy from the sun too. The moon absorbs some of that sunlight. It turns it into infrared radiation and shoots it back out. But at nighttime on the moon, it gets down to negative 135 degrees on the moon. That definitely doesn't happen here on Earth. So how come the Earth stays warm, but the moon doesn't? Well, the answer is because of our atmosphere. Again, that's the air around the Earth. The atmosphere is what keeps us warm. You can think of it like a blanket laying on top of the Earth, trapping energy from the sun and keeping us warm. Just like when you're cold and you put on a blanket and that traps energy to keep you warm, the atmosphere does the same thing to the Earth. Now the moon, it basically has no atmosphere, so any energy that comes into the moon gets shot back out into space again, and it's lost. There's nothing there to trap the energy to warm up the moon, so the moon stays really cold. Here's a picture of the Earth from space, and you can see this layer, this kind of bluish glow around the Earth. That's the atmosphere. So again, think of it, it's like a blanket of gases that keeps the Earth warm. So how does the atmosphere actually trap energy? Well, the atmosphere, remember the ground turned that light energy into infrared radiation, and that infrared radiation kind of shoots back up towards the sky. The atmosphere is going to trap, it's going to catch some of that infrared radiation, and that trapped infrared radiation warms up the Earth, and that's what keeps the Earth actually warm and lets us have the temperature that we have. So without the atmosphere, it would actually be too cold for life to exist. The atmosphere is important because it warms up the Earth enough so life can exist. And how does the atmosphere trap that energy? Well, there are specific gases in the atmosphere that do this, and they are called greenhouse gases. So why greenhouse? Well, if you've ever seen one of these, this is a picture of a greenhouse. You can see it's made of glass, and they use greenhouses to grow plants in the wintertime. Because what glass does is the sunlight can come in through the glass, but then inside that sunlight again gets transformed into infrared radiation. But infrared radiation can't exit glass. So infrared radiation gets trapped by the glass and it gets really warm inside of the greenhouse. So that's exactly what the Earth's atmosphere does to keep the Earth warm. However, obviously the Earth is not surrounded by glass. The Earth is only surrounded by these gases. And there are certain gases, they kind of act like the glass to keep the Earth warm. So we can see, here's what happens on the Earth. The sunlight comes in. Some of the energy shoots back out into space and is lost. But some of the energy gets trapped by these greenhouse gases and it's stuck in the atmosphere and keeps the Earth warm. And some of the gases that do this are water vapor, carbon dioxide, methane, and nitrous oxide. And carbon dioxide is kind of the most important greenhouse gas. That's the one you hear people talking about a lot. We're going to talk a lot about that in this project. So think one way you can think about this greenhouse effect is, let's say you have a car that's been sitting out in the sun for a long time. The energy from the sun goes in through the windows of the car, gets transformed into infrared radiation, but then that energy gets trapped. It can't escape the car, so it gets really hot. That's why if a car's been sitting out in the sunlight for a long time, even if it's kind of cold outside, it can be kind of warm inside because of all that trapped energy. The Earth's atmosphere, again, does the same thing. The light from the sun comes in, transforms into infrared radiation, but some of that infrared radiation gets trapped by the atmosphere and it warms up the Earth. It's important to know that when we hear about the greenhouse effect, a lot of times we're told it's a bad thing. The greenhouse effect is actually a natural part of how the Earth works. We could not be here without it. It would be too cold on Earth without the greenhouse effect. So if there's too little greenhouse gases, the Earth is going to be too cold for life. Too much energy is going to escape out to space, and we would all freeze to death. But if there's too many greenhouse gases, the Earth is going to trap too much energy, and then it gets too hot. So we really need the greenhouse gases to be just the right amount. It's called, think of it like Goldilocks, not too hot, not too cold, just right. We need the greenhouse gases at just the right amount to trap the right amount of energy so it's warm enough for us to live, but not too warm. You can actually look at other planets to get an example of what happens when there's too many or too few greenhouse gases. So here we are on Earth. We've got just the right amount of greenhouse gases, and that makes the temperature about 15 degrees Celsius on average, which is like just right for life. But what if there were too few greenhouse gases? Well, we can look at Mars. Mars has very, very few greenhouse gases. And you can see that with very few greenhouse gases, Mars's temperature is about negative 47 degrees Celsius. That's really cold. That's too cold for life to exist. So when you have too few greenhouse gases, it's way too cold. Now, Venus is another planet in the solar system. Venus has something like 90 times the amount of greenhouse gases that we do. And look at its temperature. Its average temperature is 477 degrees Celsius. That is incredibly hot. That clearly is way too hot for life. So you can see that when you have a lot more greenhouse gases, you trap a lot more of the sun's energy, and it gets a lot hotter on the planet. So that's an overview of the greenhouse effect, where we get energy from in the sun, and how greenhouse gases trap that energy from the sun to warm up the Earth's atmosphere. Now you're going to use this information to continue through step 6, which is climate task 2.